Today we are going to review Learning Target 6.2, which is all about solving systems. So remember, we talked that there are 3 ways to solve a system of equations. We've got graphing, substitution, and elimination. So let's go ahead and take a look first at graphing. This was the very first thing that we did in order to solve a system. So remember, the best method to graph would be get the equations to say y equals, because then we can identify the slope and the y-intercept. So our example here is that y equals -5/2 x plus 3 and y equals x minus 4. So the nice thing about this is that we already have y equals. We already have it into that form of y equals mx plus b, where remember m represents our slope and b represents our y-intercept. So I am going to identify the slope and the y-intercept from each of these lines. So if I take a look at that top equation, we are going to identify the slope as the number that's in front of the x. So notice that the number in front is -5/2. I do not put an x with it. Slope is just the number in front. But remember, slope, we want to think about it as rise over run, meaning the number on the top, you move up and down, and the number on the bottom, you move left and right. So that negative sign can go with either the 5 or the 2. So in this case, I kind of wrote it with the 5. So that tells me that since I'm moving up or down, if the 5 is negative, I'd have to move down. The 2 is positive, so that means we'd move to the right. Had I put that negative on the bottom, well, then that tells us that the 5 is positive, so we'd move up, and the 2 is negative, so we'd move left. So 2 different ways to think about graphing that line with that slope. The y-intercept is the number that is not connected. I like to write it as an ordered pair. Remember, 0, comma, and in this case, it's a +3. So it's important to have that point because that's where we're going to start. So I'm going to graph this line. So 0, 3. Well, remember the y-axis is this vertical line. So 0, 3 is up here. So now I'm going to follow my slope. So if I have the -5, that means I'm going to go down 1, 2, 3, 4, 5 from that y-intercept. And then I'd have to move 1, 2 to the right. And then I could do it again. 1, 2, 3, 4, 5 down and 2 over to the right. Notice how my graph's going to run out of room if I try to keep going down. So I'm going to go back to my y-intercept, and I'm going to do it the opposite. I'm going to have the 5 positive, so I'm going to go up 5, 1, 2, 3, 4, 5. But then I'd have to go 2 to the left. And notice that all of those points are nicely on my graph, and it allows me to then connect them where I have one nice straight line that takes up the entire graph. Now I'm going to look at that second equation. Since it says y equals, we already can identify the slope and the y-intercept right away. If I don't see a number in front of the x, we can always think of it as a +1. So I'm going to think of it as a fraction, though. I'm going to do 1 over 1. So because it's positive, I'm going to move up and to the right. However, we could do the opposite. We could go down, but then we'd have to move to the left. So those are the 2 ways to then move to get that slope. Notice that my y-intercept, once again, would be 0, comma, whatever the number is that's not attached. But look very carefully. It's not just 4. There's a negative sign in front of it. So 0, -4 is going to be the y-intercept. So that's my starting point. So down at -4 on the y-axis is where I'm going to start. And so then if I go up 1, I go 1 to the right. Up 1, 1 to the right. Up 1, 1 to the right. I could keep doing that as many times as I want. Okay, notice that if I wanted, I could go from -4, I could go down 1, but then I'd have to move 1 to the left. Down 1, 1 to the left. Okay, I have quite a few points here. That's going to allow me to draw my nice straight line. And also notice that it hits and intersects through that other line that we just graphed. So my final answer, my solution, is the ordered pair where they intersect. So hopefully you notice that this point right here is the point that intersects. And when we're talking about an ordered pair, remember x goes first and y goes second. So if I'm looking on the x-axis, notice that it's lined up with that positive 2. So that's my x. But then I had to move down and notice that for the y, it's lined up with negative 2. So 2, negative 2 would be the solution when I graphed. Okay, the second way that we learned how to solve was through substitution. And so in order to do substitution, you want to have a variable by itself, so then we can replace that in the other equation. So right now, if I look at my problem, I've got negative 5x minus 4y equals 17. So the top equation, I don't see x equals, or I don't see y equals. So I don't see a variable by itself. If I look at the bottom equation, I've got 4x plus y equals 4. Once again, that bottom equation, I don't see x equals or y equals. However, we can get a variable by itself. We want to have a positive 1 in front in order to do that. So hopefully we pinpointed it at it's the y in the bottom that has that positive 1. So I'm going to take that bottom equation, and I am going to resolve this for y. So to get y by itself means I need to move the 4x over to the right. So what's the opposite of a positive 4x? Well, that would be a negative 4x. So I subtract 4x. That will get me now the y by itself. So y is going to equal, and then those are not like terms. Remember, 4 and a 4x are not the same. So I can just write it as 4 minus 4x. Now that I have that variable by itself, remember, I like to put an arrow next to the equation that has the variable by itself. The top equation, we haven't done anything to. So I'm just going to rewrite it right below here, just so then I can now focus on, I can focus on this. So this is my new system to look at. And so because now I know what y equals, I get to take that value and I get to substitute it into the y in the now bottom equation. So I am going to have, I'm going to write it over here. We're going to have negative 5x minus 4, but now instead of having that y, I'm going to replace it in parentheses with what y equals, which is 4 minus 4x. I have to finish the rest of that equation. It equals 17. So notice that now I have an equation that only contains one variable. It contains x's. There are no y's. So that's perfect. I want to get rid of the parentheses, so I'm going to distribute. But notice that it's a negative 4 that I'm going to distribute. So the negative 5x stays as it is. Negative 4 times 4 is negative 16. Negative 4 times negative 4x, well, a negative times a negative is going to make that a positive 16x. This still equals 17. Notice that in this equation, on the right-hand side, we have two things that still have x. That means we can combine those right away. Negative 5 plus 16 is going to give us a positive 11x. We still have minus 16, and this equals 17. So now I've got two numbers on the same side as x, so I'm going to start solving. So I'm going to add the 16 over to the other side. That will give me 11x equals, when I combine those, I'm going to get 33. I'm going to divide by 11, and that gives me a value of x to be 3. So the moment I was able to get a value for x, that means that my solution is going to be an ordered pair, where remember, x goes first in the ordered pair and y goes second. So x we got to be 3. I'm going to put that then first in my ordered pair. But I'm not done because I need to get the y. So remember, that's why if I go back over here to where that big arrow is, it says y equals. I can substitute 3 in for x, and I can very easily find what y is. So y is going to equal 4 minus 4 times 3. So if I start simplifying, I'm going to multiply this 4 times the 3, which will give me 12. And so 4 minus 12 is going to give me my y value. Well, 4 minus 12 is negative 8. So 3, negative 8. Once again, it would be a good idea, especially on the test, to go and check because you should 100% know if your answer is correct by checking. So I can take this 3, negative 8, and if I go back here to my original system before I did any type of maneuver, I can plug 3 in for all of the x's, negative 8 into all of the y's, and make sure I have 2 true statements. So I'll have negative 5 times 3 minus 4 times negative 8, and I want to double check that that really equals 17. Well, negative 5 times 3 is negative 15. Negative 4 times negative 8. A negative times a negative is a positive, and that 4 times 8 is 32. I want to make sure it equals 17. Well, negative 15 plus 32, if you put it in your calculator, you will get 17. So far, so good. It checks out. Now I have to put those numbers into the bottom equation. So we'll have 4 times 3 plus, you can put 1, or you don't even have to write the 1, but I need to then multiply that by negative 8, and that's going to equal 4. Well, 4 times 3 is 12. 1 times negative 8 is negative 8. 12 minus 8 is going to get us 4. So notice that it checks out. We have 2 true statements, so we know that we are set. That 3, negative 8 is a solution. So that's how we would do substitution. The last one that we talked about was elimination. So remember, in order to do elimination, you want all of your like terms lined up. So if we look at the equation, notice the x's are together, the y's are together, the equal signs are together, the numbers are together. So it's already set up for us to eliminate. We want to try to add up the columns, and the whole point of elimination is that one of the variables will eliminate or disappear. So if you have opposites, they should add to 0, which will then make a variable disappear. We'll notice that the top x has a positive 10, the bottom x has a negative 10. Those are opposites. If I add 10 and negative 10 together, it's going to give me 0. So that tells us that this is already good to go. We can eliminate. So the x's cancel. I'm not actually going to cross them off because I'm going to need these equations later, but the x's turn to 0, so that goes away. Now I can add up the y's. Well, negative 5 plus negative 3 will give us a negative 8y. If I add up the numbers, negative 15 plus 7 is going to give us negative 8. We can then solve for y by dividing both sides by negative 8, and we get a value of y to be positive 1. So since we were able to come up with a value for one of my variables, I know my solution is an ordered pair where x goes first and y goes second. So because we solved for y, I get to put that number second. We now have to solve for x. And so that's why I didn't cross off any of the x's when we eliminated them, because now I have to go back to my original equations, and it doesn't really matter which one we go back to. Since I want to solve for x, I noticed that there's a positive number in front of the x in the top row, so I'm just going to pick this equation. So I'm going to solve for x by substituting 1 in for y in the top equation. So we'll have 10x minus 5 times 1, and that equals 15. Well, 5 times 1, there'll still be that subtraction sign there, but 5 times 1 is 5. Now I want to get those numbers away from x. So I'm going to have to move the number not attached. That negative 5, we need to add it. That goes away. We'll still have 10x. This equals negative 15 plus 5, which is negative 10. And then we'll have to divide both sides by 10, and we get a value of x to be negative 1. So once again, I have a solution, but you will know 100% if you are correct by now checking that solution. So I'm going to go back to both of those original equations, plug negative 1 in for x and positive 1 in for y. So we'll have 10 times negative 1 minus 5 times positive 1, and we want to make sure that that equals 15. 10 times negative 1 is negative 10. Negative 5 times 1 is negative 5. And notice that if I put that in my calculator, negative 10 minus 5 is negative 15. So that one checks out. If I go back to the bottom equation, we'll have negative 10 times negative 1 minus 3 times positive 1, and we want this to equal 7. Well, negative 10 times negative 1 is positive 10. We'll have negative 3 times 1, which is negative 3. And notice that 10 minus 3 will get us 7. So it checks out. We know that this negative 1 ordered pair is our solution. Let's do elimination one more time with this example. We've got 4x plus 7y equals 0, and 12x plus 21y equals negative 12. So notice that my x's are lined up, the y's are lined up, and the equal signs and the numbers are. So it's set up good. If I tried to then add these together, 4 plus 12 for the x's, that's not going to add up to 0. So that won't eliminate. If I look at the y's, 7 plus 21, that's also not going to add up to 0. So we have a problem. I am not going to be able to eliminate right away. So this is where we have to try to manipulate an equation by multiplying the entire equation by a number in order to eliminate. So notice that if I look at the x's, 4 is smaller than 12. So I want to try to ask myself, can I multiply 4 times something to get 12? And hopefully right now you're following along and saying, yes, 4 times 3 will get me 12. But now because the bottom number is a positive 12, we want the top number to be a negative 12 because I want the same number but opposite signs. So I am going to take this entire top equation and I'm going to multiply by negative 3 because 4 times negative 3 will get me that negative 12. So I'm going to distribute that negative 3 to everything in the top equation. So like we said, 4x times negative 3 will be negative 12x. 7y times negative 3 will be negative 21y. That's going to equal 0 times negative 3, which is still 0. We didn't have to multiply anything in the bottom equation, so I'm going to keep that as it is. But now I can add up my equations because once again, negative 12x plus 12x, that's going to turn to 0. If we look at the y's, negative 21y plus 21y, these are opposites as well. So that's going to cancel. So if everything on the left cancels, then I just have 0. On the right-hand side, we have 0 plus negative 12, which will be negative 12. So notice that in this problem, all of my variables disappeared, which means that my solution cannot be an ordered pair. If I don't know what x equals or y equals because we lost both of those variables, we're not going to have an ordered pair, but instead we'll have either no solution or we'll have infinitely many. Now in this case, because I have 0 equals negative 12, if it's a true statement, we'll have infinitely many solutions. If it's a false statement, we'll have no solution. The fact that 0 does not equal negative 12, if it's false, think no, you can't have that. So that means we have no solution. And because we have no solution, there's no way for us to go back and double check that our answer is correct. So we just have to know that because we have a false statement, we have no solution.